With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is that the concentration of R in the reaction R to P was measured as a function of time, and the following data were obtained. What is the order of the reaction? So this is the data that you get about the concentration of R and the time. Okay. Now, if we talk about this reaction R to P, how do you express the rate of the reaction? That is the rate of disappearance of the reactant, right, which is minus dR by dt is equal to the rate of appearance of product, which is plus dP by dt, right? This gives you the rate. Okay, you can represent rate by R. So basically what do you understand from here? That the rate of disappearance is shown as negative because whenever the reaction proceeds, the reactant is converted to product. So the concentration of reactant decreases. That is why a negative sign is there. And when as the product formation is taking place, therefore a positive sign depicts the formation of product, right? Now, what we can do is we are given the values for rate and time, the concentration of R and time here. So let us calculate the first rate, right? Which will be when the concentration changes from 1 to 0.75 in 0 to 0.05 minutes, right? So what will be the R1? The change in concentration, right? R1 will be the change in concentration of the reactant, which will be 1 minus 0.75, right? Divided by 0.05, right? This is how you will calculate it. So this will be 0.25 divided by 0.05. This will come out to be equal to 5. So how do you calculate the rate? The change in concentration divided by the time, the change in time, right? So this will be 0.05 minus 0. So actually this is what we are going to get. Now let us calculate R2, which is for the values 0.75 to 0.40 when the concentration decreases from 0.75 to 0.40 and the time increases from 0.05 to 0.12. How will you calculate the rate? R2 will be equal to 0.75 minus 0.40 is equal to 0.12 minus 0.05. Okay, this will be equal to what? 0.35 divided by 0.07, which will again be equal to 5. Similarly, we can also calculate R3, which will be the change in concentration from 0.40 to 0.10, right? This will be 0.40 minus 0.10 divided by 0.18 minus 0.12. Okay. This will be equal to what? 0.3 divided by, and this will be equal to 0.18 minus 0.12 will be 0.06. So again, this will be equal to 5. So what do you observe? What do you observe? That for every change in concentration, the rate is remaining the same, right? You can say that rate does not change on decreasing the concentration of the reactant, right? What you observe is that we are decreasing the concentration of reactant, but it is not affecting the rate. The rate of the reaction is remaining the same, which means that this reaction is a zero order reaction, because if we talk about a zero order reaction and if we write the rate law for that, it is written as R is equal to A, because if suppose R is the reactant, or you can say A is the reactant, it varies as K is equal to A to the power 0, which comes out to be R is equal to K, which means that for a zero order reaction, rate is a constant, and that is what we have observed here for all the values, right? Therefore, this is going to be a zero order reaction. That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.